In this problem, we are told that John drove from his home to the store with an average speed of 40 miles per hour. Let's assume it took him an amount of time t1 in order to get there. He then drove home along the same route or the same distance at an average speed of 30 miles per hour. Let's assume it took him an amount of time t2 in order to get back home. The distance he would have traveled to get to the store is equal to 40 times t1. Since he drove home along the same route and traveled the same distance, the distance he traveled can also be expressed as 30 times t2, since he traveled 30 miles per hour and it took him t2 hours to get back. We are told that the total amount of time he spent driving was 1 hour and 10 minutes. Therefore, the total time he spent driving was 1 1/6 hours. And that would be equal to t1, the time it took to get to the store, plus t2, the time it took to get home from the store. Since from the distance relationship, we know that 40 t1 is equal to 30 t2, we can multiply both sides of the equality by 1/40. The 40s on the left-hand side cancel, and we see that t1 is equal to 30 over 40 times t2, which can simplify to 3 over 4 times t2. We can then plug that relationship for t1 into the first equation. Therefore, 3/4 times t2 plus t2 is equal to 1 1/6, which is just equal to 7/6. Summing the terms on the left-hand side, we could see that 7/4 t2 is equal to 7/6. If we multiply both sides of the equality by 4/7, the 4's and the 7's on the left-hand side cancel, and after canceling the 7's on the right-hand side, we see that t2 is equal to 4/6. Since we were asked for the distance traveled to the store, we can simply take this value for t2 and plug it into the distance equation above, which shows that the distance traveled to the store, or from the store home, which is the same distance, is equal to 30 times t2, which is equal to 30 times 4/6, and since 30 is equal to 6 times 5, we can cancel the 6's, and we find that the distance traveled to the store is 5 times 4, which is 20 miles.